Okay, Bismillahirrahmanirrahim. We continue our chapter 4 on the subtopic electromotive force, EMF. So, what is electromotive force? Electromotive force is the potential difference between the anode and cathode in a cell. It is also called the cell potential and is designated with E0 cell. This value measured in volts, and E0 cell is a value at standard condition. So what does it mean by standard condition? Remember, when the concentration of electrolyte is 1 molar, temperature 25 degrees Celsius, and pressure is 1 atmosphere. Okay, so that is the E0 cell or EMF. So look at the example, how to calculate the E0 cell. Okay, if we build a cell, we need to have cathode and anode. So how to calculate the E0 cell? E0 cell is equal to E cathode minus E anode. Okay, and E cell is equal to E oxidation plus E reduction. Okay, this is standard reduction potential value, or we call it SRP. So this is the value. This is a constant. You don't have to memorize this. It is given, inshallah. The importance of the standard reduction potential is to identify the cathode and anode. Okay, because sometimes we use silver as a cathode. Sometimes we use silver as an anode. So, if we want to know whether it is a oxidation or reduction, we refer to this table. Okay, and this table is also used to determine the E cell for the reaction. More positive anode, it is cathode. Means that it is a reduction reaction, and it will act as cathode. It will be more easily electron is added to the reaction to the cell. More easily reduce. Reduce is gaining electron. Remember that one. It is better oxidizing agent. Oxidizing agent being reduced. Okay. So you have to remember back your redox reaction in your semester 1 chemistry. Okay, so that is more positive value. If for value that is negative, the more negative the E0, it is oxidation, and it will react as anode. Okay, if let's say you use which one? Okay, this one. Kita ambil manganese dengan zinc. Manganese will be anode, zinc 2 plus will be cathode. So this one, these two. Okay. The more the negative the E0, the more easily electron is lost from the cell. So it will be oxidized, because oxidation is losing electron. When it is oxidized, being oxidized, it will be a better reducing agent. Reducing agent will be oxidized, oxidizing agent will be reduced. And now we look at the standard hydrogen electrode. So what is standard hydrogen electrode? Or She, we call it She, S-H-E, She. It is a reference to standard reduction potential value. Kalau kamu tengok balik dekat table yang tadi tu, She ataupun this equation is located at the middle with the value of 0. Above which is positive value, below which is the negative value. Okay. So how to, by definition, the reduction potential for hydrogen is 0. Yeah, this is a reaction that happened in the electrode. Yeah, two hydride ion gain 2 electron and being gaining, yeah, reduction will be reduced to hydrogen gas. Okay, and this is how She electrode looks like. Yeah, because hydrogen is not solid, so we need to have this. Yeah, we use platinum electrode or inert electrode. Yeah, any inert electrode we can use, but in this case we use platinum electrode. Hang to the external circuit, and this glass is to allow the hydrogen gas being flow in. Yeah, and this is platinum wire. Okay, in this reaction, yeah, in this electrode, the platinum atom will be oxidized. Yeah, will be oxidized and donates the electron to hydrogen from water. Okay, and water will be hydrogen from the water will be reduced to form hydrogen gas. Yeah. Okay. So that is how reduction and oxidation happen in the She electrode with the platinum electrode. Okay. Yes, this is hydrogen gas. This is water molecule. Okay. Okay. So now we look at the calculation of cell potential. How to calculate the E naught for cell? Yeah. So look at this example. Determine the cell potential E cell for a voltaic cell that use zinc and copper half cell reaction. A given E naught. E naught cell for zinc is negative 0.76 and volt, and E naught copper is positive 0.34. Yeah? So remember, the negative, the more positive the value of E naught, SRP, will make it become oxidation. Yeah? So it will react as anode, as cathode. The more negative the SRP value will make it as anode, because it will be reduced. Yeah. So this one, yeah, you just solve this calculation. You will get the value for E cell of the zinc and copper for voltaic cell. Yeah. Okay, you can use either this calculation or this calculation. You will still get the same value. Yeah, same answer. Okay. We continue with the cell notation. We call it cell diagram. Yeah. So what is cell notation? Cell notation is actually a short form or shorthand. We call it shorthand. Simplified way to write the electrolytic cell. Okay. This is the cell notation. Okay. This one. Tak perlu nak tulis, nak lukis banyak. Okay. So for cell notation, we have component of anode and component of cathode. Yeah? Anode is where oxidation half cell reaction happen. Cathode is where reduction half cell reaction happen. Yeah? So on the left, we write the electrode. Yeah? Then we use this symbol. Yeah? Memang sama macam ni. Cuma yang ini dibuat besar lah sebab tulisan ni besar sikit. Then phase of lower oxidation state on the anode, if we have, kalau tak ada tak apa. Then phase of higher oxidation state, ya. Kalau yang ini yang ni tak ada. Yang ini for example 1, there is no phase of lower and higher. Dia ada electrode dengan electrolyte sahaja. Okay. Then we put a double line ni macam ni. Yang ini as a symbol of salt bridge. Then we move to the cathode compartment. Phase of higher oxidation state, phase of lower oxidation state, and electrode. Okay, we look at example 1. We have zinc electrode, anode. Then we have zinc electrolyte. Then we get we put a salt bridge. Then we get another electrolyte on the cathode compartment. Then we have copper electrode, which is act as a cathode. Okay. So from this, we can, if you are given with the cell notation, you should be able to come out with the half cell reaction. Or if you are given with the half cell reaction, you should be able to construct your cell notation. Okay. So for example 2, this is a bit complicated because we use inert electrode, graphite. In this case, we have graphite. We have a few inert electrode. You can Google. We have previous example. We have platinum. Now we have graphite. Okay. So graphite is an anode. Then we have phase of lower oxidation state. Iodide ion. Then we have iodine solid. Okay. Then we have a salt bridge. Okay. Then we have on the cathode compartment, we have phase with higher oxidation state, hydrogen, aqueous, hydrogen and manganese oxide for minus, then we put a border for to differentiate between two phase. Then we have phase of lower oxidation state, manganese 2 plus. Then we have cathode, the electrode. Again, still we use a graphite. Okay. So at anode, this is the half cell reaction, on the left hand side. And at cathode, this is the reaction for the reduction half cell. Okay. Again, if you are given with the cell notation, you should be able to come out with the half reaction. If you are given with the half reaction, you should be able to construct your cell notation. Okay. Okay, I think we stop here first. We will continue in the next video on the spontaneity of the reaction, to identify whether the reaction is spontaneous or not. Okay, by then, thank you. Assalamualaikum.